Hello guys, welcome to a new video. Today I'll be making a short video. We'll be talking about DCIMs, basically data center infrastructure management systems. And before I spend much more time, let's get into it. There are basically five core components within this system that we need to be aware of. First of all, environmental monitoring captures data on temperature, pressure, humidity, and airflow to identify inefficiencies. Also, adding on to the fact that how the environment is changing, if there's a big mass of, let's say, heat moving around, if the temperature is not the ideal temperature that you would want, such and such, and how they are moving in the sense of air, how air is moving, and let the engineers know before it's late if there's going to be a problem. Power monitoring provides visibility into the entire power chain, generates the outlet, allowing for problem diagnosis, load balancing, and trend analysis. How such people are uh, in this explanation, maybe you might be confused with what trend analysis is. So I'll explain that. Trend analysis basically being that if, let's say, people are doing more work at such hour, let's say at 5 p.m., people are going more towards the bank because they are out from their job. They just got out from the job. They they left the, let's say, place that they usually go, and there's let's say surge in incoming requests to the data center. Therefore you use more power for that hour, so you need to manage how the power is working as such. This is why it matters. And obviously power monitoring means generator to outlet, like how everything, how much power they're using, what such is going on, how much power servers using, and the neighboring server if it's using more than that or not. Such and such is what that means. Capacity planning. Insights into current capacity for power, cooling, network connectivity, and space, helping to optimize layouts and forecast future needs. As it explains pretty simply, capacity planning is basically how much space you have and how much you can basically utilize that space, and that's why you need to plan your capacity. Asset management maintains a centralized database of all IT and facility assets, detailing location, connections, ownership, and maintenance coverage. Basically, how the assets are moved around, and you need to manage those assets because like it says here, the IT, the facility assets, ownership, maintenance, coverage, all of these need to be managed by something. This is why the asset management exists. Change management automates processes for moves, adds, and changes with real-time tracking, improving productivity and compliance. Whole, like, let's say if the processes for moves, adds, and changes, real-time tracking. This means like if you are moving something, everyone's aware of that management, and you improve that productivity with making this management more planned, like in a sense that you know that A is going to B and B will be covered by C. Therefore, you handle it with D. And what all of this basically means is that you actually just do a planning for when you're gonna change stuff. And it says automates process for moves, adds, and changes. The scale of the challenge. Data centers are massive operations filled with, sorry, millions of servers and miles of cables that must run 24/7 without failure. Managing tons of assets manually, like using spreadsheets, is described as nearly impossible. And reasoning for that is quite simple because there's so many requests, and even if there weren't, even if it was, let's say, only the electrical part that matters, there's so much you need to take into consideration, and normal human cannot do that. What DCIM actually does. DCIM acts as a digital twin or a single dashboard for our entire facility. It allows operators to see every rack and server in real time. Okay, we're still on record. Monitoring power usage, temperature, and status without needing to physically walk the floor. You do this with sensors, and you put this into a program where that all of these should work, which we'll come to. Proactive management. The software moves beyond just viewing data to actively managing it. It can spot issues like overheating or power spikes before they become critical failures, sending alerts to engineers immediately. Like we said, let's say a temperature might be rising in environmental monitoring, and the system immediately warns the engineers there's a spike. A spike is going to happen, so you need to be aware of this situation because if it goes up one at a time and you don't notice it, the server will be cooked, you will be cooked, and it will be in the literal sense of a fire. This is extremely important that you prevent errors before they can actually happen. This is why we need it. Sustainability and efficiency. DCM helps fine-tune cooling, power usage. All of these basically for fine-tuning, like it says, that it's a really good use of the word, that you just do all of this so you are more sustainable and you are more efficient, so you make more money, like all the companies want. You just do not want to lose money, so this is why. These are some of the softwares that actually do this. Schneider Electric Exostrator, a cloud-based solution that benchmarks performance worldwide, needs software specialized in detailed asset management. Device 42, known for automatic discovery that maps every device on the network. EcoSense focuses on cooling with 3D visualization. Sorry, visualization. AKCP integrates environmental sensors with video alerts. Sunbird prays for a simple, elegant yet powerful interface. You could use a software such as these. These are just examples from the sources that I used from those videos that I use in every video I use. The videos I mean that I take as sources. Anyway, these are some of the examples that I could give you. Like you can use these softwares if let's say you have a system that you need to protect or make sure it works properly. These are basically the DCIM softwares and what it stands for. PUA. PUE. Power usage effectiveness. Definition and formula. PUE is a ratio calculated by dividing the total facility load by the IT load. Total facility load includes energy consumed by cooling, network lighting, and IT equipment. IT load includes energy consumed specifically by servers and the computing equipment. So the servers and the computing equipment is what like people are doing or inside the place. And total facility is like including the IT and the servers, all of the total facility load. Purpose. This metric helps managers compare the energy and money spent on the total facility expenses versus the energy spent on the servers, revenue generating assets. Ideally, you want to bridge the gap between these two figures. The ratio, a P of 1 indicates total efficiency, energy spent on facility equals energy spent on IT equipment. A higher PUE, example being 10, indicates high inefficiency. The average P for data centers in 2020 was 1.58. And imagine this was in 2020, so these days is probably much higher than this. I think it is around 1.30 mayhaps, and I am not entirely sure. Perhaps it is around that. I'm not entirely sure. You can look it up. I mean, it is an interesting topic. If it wasn't, why would I be talking about it? Variable. Speed is relative and influenced by factors like data center's function, equipment, and geographic region. Weather differences between Seattle and Florida. Obviously, it depends on what country you're in, what place you're in, how the whole like what is the humidity, how hot is the air, what's the temperature like, how the sorry, how dirty is the air, such and such, and all of these actually matter a lot in the sense that you actually want to make sure that you're spending green energy. This is what the ICIM is actually really useful for also, that you want to make sure you're using green energy rather than, relying on, let's say, fossil fuels. Let's say, mm, I mean, there's basically fossil fuels There's not much that can make the planet even worse than it is. Basically, it means that you should use more green power, and these make sure the companies stay under the lines because, as we know, countries are banning usage of sorry, high levels of fossil fuels for your power systems. You cannot just waste so much energy and water because you need cooling and you need energy. You cannot just do all of these. So these programs and these metrics help you make you more efficient and make the world a better place. Improving a common methods for to lower P include hot, cold aisle containment and liquid cooling. And for these, you can go back to my old videos. But if I were to just explain in a simple manner, hot, hot, cold aisle basically means one side of the aisle is cold and the other one is hot. And you use this efficient technique to circulate air in there so you can actually make the place cooler and make the cooling process more efficient. And liquid cooling is, as you all know, it is done with water and is already an really efficient method as it was in the past, as always. But this is all I'm going to talk about today. Uh, Before I end the video, you can always comment if you have any questions or if you want to say anything to me. If you want to complain about something that I did that you didn't like, who knows? And I'll be making sure that I look them up in my next video, so I don't disappoint you again. Thanks for watching, and this is all I have. Good night.